Hello, everyone. I'm going to talk to you about the power of Crystal, which is a programming language that's intended for humans and computers. And I'm going to give a short introduction into what Crystal is, how it works, how it relates to Ruby, and how you can use both together to get the combined power of the two. And at the end, I'm going to have some learnings for Ruby developers. Like if you go out of this talk and say you never want to have anything to do with Crystal ever, then you can still get some learnings that maybe help from a Crystal perspective looking at Ruby, what can be good ideas for your Ruby development, making you a better Ruby programmer. So if you want to follow the slides, you can follow this QR code. They're going to be available later as well. At the bottom, I have some links. If you want to install Crystal, try it out. Or there's also an online playground, which is basically a full Crystal compiler and lets you just run Crystal in your web browser. I'll leave this slide on for a moment if you want to copy something. So my name is Johannes Müller. When I first learned Ruby, it was the first time I really fell in love with a programming language because Ruby is so great. It was a lot of fun. And I really enjoy working with Ruby. And later, I got in contact with Crystal, and it was the second time I fell in love with the programming language. Crystal expands upon the Ruby and adds some extra flavor that I find really attractive. Crystal was, at the time that I met the language, was very young. It still is quite young. At the time, there were lots of things missing in the standard library, and I started adding them and became a contributor. And eventually, I joined the core team of the language, and now I'm working on Crystal full-time. I'm the principal engineer at the Crystal team at Manas. That's the company where Crystal was born, and which continues stewardship of the project. Manas is a software agency. We develop software for clients. It works for international clients, and the team is also international. So I'm based in Germany, for example. My colleagues are in Argentina, in France, the US, whatever. We use at Manas very different technologies, depending on the needs of the clients and the project and all of that. But we use Ruby quite a lot, especially Ruby on Rails, and we have a lot of love for Ruby. Because Ruby has some really great properties. Like it has a user-friendly syntax, it's versatile, you get productive with it. You can get a lot of done with very little work. It's simple and intuitive to use. I just picked some examples here. I'm sure we could continue this list for quite longer. And all of this greatness of Ruby is the result of the creator's vision. So a couple years ago, there was a guy in Japan who thought, what would a really good programming language look like? And he realized his vision in the language Ruby. Many people more or less agreed with this vision, and they followed using it, found it useful. Probably, the approval rate of Ruby is really high here as well. And so it was at Manas as well, and it still is. Then there's this one guy in Argentina. His name is Ari Borzenzweig. And he thought, what if Matz's really good programming language could somehow statically compile? What that means we get into a bit later, but what came out of it was Crystal. So not directly. First just started experimenting on Ruby, the Ruby syntax, and what you could do to make it like statically compiled. Presented that to his colleagues who find it interesting, and out of that somehow evolved this language that we now have. Grew into a language, an ecosystem, and a community. And it's useful to many other people as well. In this way, Mats became the grandfather of Ruby with his idea of having a good programming language. The reason why you even want to change anything about Ruby is that, as everything, Ruby also has some downsides. Again, I just picked some things here. could probably continue this list as well. Type checking in Ruby, you have some options nowadays with like RBS or SOB, but these are bolted on. They're not really part of the core of the language. They are later additions and have some challenges how to use them and use them usefully. Then Crystal is certainly not known for its like raw performance. Also, like this has improved a lot with Ruby 3 and just-in-time compilation. It can be much better than earlier versions of Ruby, but it's still like really a different level of efficiency compared to like really native code that is optimized for a specific CPU architecture. If you put out everything else, Ruby requires a language runtime and lots of dependencies, and it can be hard to distribute software written in Ruby. For this point, I'll just defer to Andy's earlier talk about packaging Rails applications for on-premise use. And also concurrency is a thing that I think in Ruby is not very great. Not sure if anyone has ever tried producing any concurrent software in Ruby that doesn't like use the web server front end for managing all of that. It can be an adventure sometimes. So programming language is always a compromise, like everything else. Like you have some features and you have some non-features. You can try to pack everything together and have all the features of all the languages, but that really won't work because they are sometimes mutually exclusive. You can try piling stuff on top, but at some point you have some things that don't work well together. Particularly for Ruby, it's a very dynamic language. You can do lots of things, have a lot of power, but that limits some optimizations that you could do. Crystal's answers here are that it takes like all the good things from Ruby, most of them, and adds some more on top. So Crystal basically shifts a bit the feature set towards being more static, which of course loses some of the dynamic nature, but it tries to avoid having that much impact of that dynamic loss. So it still feels very dynamic if you use Crystal. So it has static typing, but it has type inference, which makes like, if you think about statically typed languages, maybe like Java or C or something, where you have to put types everywhere. You don't have to do that in Crystal because type inference solves that for you. The compiler almost always can tell which types you're using. There are some places only where you have to explicitly type things. Crystal compiles to highly efficient machine code, and it has a strong intuitive concurrency model. This is a fresh approach upon the ideas of Ruby as a new but similar language. You can compare it maybe some way to their different dialects of Ruby with like different implementations, JRuby, Rubinius, MRuby, that kind of stuff, which are more like dialects. And Crystal is not as close as those to Ruby. It's more different, but still very close. So large places like even identical to Ruby in most of its behavior. And the good thing as a Ruby developer, you can leverage your Ruby knowledge for Crystal because it's so similar. Let's look at some of examples. So here we have a program that basically just puts a hello world with the addition that it writes the language. And this program works in both Crystal and Ruby, and it knows which language is running it. So I'm using a bit of a trick here to the stringification of the array class is different in Crystal and Ruby. We'll come to that later, why that is. But you can see there is a very common superset between Crystal and Ruby. Some programs just run in both. If you execute that in Ruby, you get your hello Ruby. If you execute that with Crystal, you get your hello Crystal. Awesome. Another example like this, if you look at it, could be perfectly fine Ruby code, I think, with just requiring an HTTP library that probably nobody in Ruby knows, because it's a Crystal library and the code is Crystal. This HTTP server implementation comes with Crystal standard library, which is really feature-rich and has lots of useful tools just right in the box. So this server is simple, but super efficient. Like this thing can handle tens of thousands of requests per second with ease and just a single thread, single process. That's all to Crystal's efficient concurrency and compilation speed. So let's get to the static typing part. So again, we have a program that could be both Crystal and Ruby, and it works in both. I have a function, a method add, that receives 2 parameters and then calls the plus operator between those parameters. As you would expect, the first call means that 2 numbers are added, and then the second call means that 2 strings are concatenated. And this works in Crystal, despite Crystal being statically typed, which means that the compiler checks all the types of all the expressions in the program at compile time. Not just when it runs, but ahead of actually running it. It knows what the type of this A plus B expression here will be if you run any of these calls, even without actually doing that. And the thing here is that the type is different depending on how I call the method add. In the first case, the return type of the method is an int. In the second case, it's a string. So there are different instantiations of the add method, one for integers and one for strings. The compiler figures all of that out via type inference, and it knows what's happening here. It also knows what happens when you try to do something that is not very practical. So trying to add a number to a string that's not defined, neither in Crystal nor in Ruby. The Crystal compiler will immediately tell you that this is a failure, as will the Ruby compiler, Ruby interpreter. But in Crystal, you will know that before the program runs. So just compiling this code, the compiler will know that this can't work because you're calling a method that's not defined. And it will tell you why it doesn't work and what you can do to make it work, like use a different type here. So this is really very valuable because if you can type a program and the typeness check, the type check turns that it works, then you can be certain that at least some level of soundness is in the program, that it can theoretically work. But if the compiler already notices that something doesn't work, then you have to do something without needing, like in Ruby, you often need to test extensively to be certain of these kind of things. But static typing excludes a whole range of errors that you get very commonly in Ruby, like running some code and then you end up with a no method error because some value is of a type that you didn't expect. And then you can't call a method on the nil class. Another example of static typing is here. We have an array. Remember earlier, the array had some parentheses after it. So that's called generic parameterization. Though in Crystal, there's not a single array type, but many variants of array. And every variant tells what kinds of items you can put in the array. So here, this array literal creates an array that contains integers. You can see that with the class name, it's an array of int32. This array, we can add more integers, and we can access elements on this array, and the return type of that will be an integer. But we cannot add a string, because this array is meant for integers. Now, the compiler just inferred that we want this array to be for integers, but maybe we don't. Maybe it should be allowed to add strings there. Then we need to tell that explicitly. We can do that with this kind of syntax, which tells at the initialization of the array that its element type is supposed to be either an integer or a string. And then it's fine. We can put integers in, we can put strings in, but we need to be careful because now if you index an array of the array, an element of the array, then we can get either integer or a string. So we may need to handle that differently, depending on what we want to do after that. But the compiler helps us here and tells us what we can do and what we cannot do. So type information like this is sometimes necessary to make a program work and to tell the compiler what exactly you mean. It's relatively rarely necessary, but sometimes it is. A common case where it's really necessary is instance variables. So the way the compiler works, it needs to lay out all the types and needs to know what type each instance variable of every type is. So we need to make that more or less explicit. It can work like here in the first example, if the instance variable bar is initialized with a literal, then the compiler can perfectly fine infer that this the type of this integer, of this variable is integer. But like in the initialize method, we have a parameter that could take any kind of value, and we need to add a type restriction here to tell the compiler that this instance variable is supposed to be a string. And I think this is like something you need to do in Crystal that you don't need to do in Ruby, but it's also super helpful to have this kind of type information because it acts as documentation, like it defines the interface of your methods. So especially for public API methods, I find it really, really helpful to always add these type restrictions because it tells you what the contract is that this method implements. Even if in most cases it's not necessary to do that, but it helps a lot. So now let's look at what compilation actually means. So earlier we just ran Crystal and then the source file, which just internally compiled it and then ran the program directly. But if we actually build it, then we call the Crystal build command with the file that we want to build, and the output is a file that's called hello in this name. In this case, it has a size of about 2 megabytes. And if you look what kind of file that is, prints out some gibberish. The important part here is it's a dynamically linked executable for the current system that I'm running here. And I can execute this file, and it runs the code. So this requires an extra step, the building thing, but then we have a really great output of that. And the runtime efficiency pays off. This dynamically linked executable is reasonably portable. So I could take this to a different machine, and assuming some preconditions are met, it would run there. So it's because it's dynamically linked, it needs some libraries to be available, like libc, a libevent, and depending on what stuff your program is using, maybe other things, like if you're using regular expressions, it's gonna need libpcre to be available. But that's usually easy to make these libraries available, or at least on POSIX systems. Most of them are often available on standard systems, and others can be easily installed. It's even easier if you link your executable statically. That means all these dynamic libraries are embedded into the executable. And then you have a result that is, in this case, a bit bigger than 2 megabytes because it includes all the dependencies. But then you can just take this file and put it anywhere, and it runs. It's at least like on the same CPU architecture, and like the kernel API needs to be somewhat compatible. But that is very helpful. Like you build something, you push it to a server, and it just runs, and you don't need to install anything for it to install there. So when Crystal builds an executable, then it uses LLVM. There's a compiler toolkit, which is also used by other languages like Rust or Swift or the C compiler suits Clang. And it's a really good tool. Like it produces super efficient code because it looks at the code and tries to optimize everything that it can. It's sometimes really ridiculous how good the code optimization is good. So Crystal just builds on top of that. It tells LLVM what the program is supposed to do, and then LLVM makes it run really fast. For compilation, we of course need to know all the code that we want to compile at compile time. So, like in Ruby, you can modify the program while it's running. That's part of Ruby's dynamic nature. Like things like eval or send, those like change what the program does at runtime. This doesn't work in Crystal, at least not the same way, because we cannot modify the program at runtime. But Crystal has some other solutions to approach these issues and makes some dynamic features available even at compile time. So keyword here is meta programming via macros. A macro is basically code that writes other code, and it executes at compile time. So none of this will be left in the executable. A macro basically looks like a def. It's just a different keyword, but then it has a name, it has a list of parameters, it has a body, and an end keyword. And you call it like a method. In this case, the macro just contains a comment, and running this code, like expanding the macro, would result in just being this code being written. So that's just it. But let's fill the body with something that's more useful. It's called getter, so let's do something that's more getter-like. The result of this is similar to what attrreader does in Ruby. It returns the value of an instance variable. And the way it works is it defines the code for a def, and the name of that def and the body of it are derived from the argument that you pass to the macro. If you have worked with templating languages like Liquid or Jinja or something like that, then it's pretty similar to that. You can do a lot more in the macro language, like there are conditionals and you can call methods and all of that. So it's super powerful what you can do at compile time. There's also things like hooks that run when a type is inherited, for example. Like this is like it works in Ruby, but just with a different mechanism because we need to do all this at compile time. Ruby and Crystal are so similar that they share many APIs. Like they're just the same as in Ruby as there are in Crystal. But there are some gotchas. So sometimes it's because Crystal just works differently. It needs to change things, like the meta programming. But sometimes there's also explicit choices to do something else than Ruby because someone thought it was better that way. One example of that is grammar, like the include method, include question mark. Like the proper form is includes with an S. So Crystal has that method and not the other. And the other is also not available as an alias. Because that's another thing about Crystal, that we try to avoid providing different paths to do the same thing if the paths are really identical. So that involves mostly aliases. So there's, for example, only a reduce method, no inject. It's only a size, no length. And like this is not to harass people that they can't use their favorite method that they want, but it's for the greater good because it's easier to just learn one concept or one name for a concept than learning two names for the same concept. Nobody gains anything from that. It's just harder for everyone, especially newcomers who read the code and then one time they see reduce, one time they see inject, and they wonder what's the difference, and the end is, well, there's no difference. Okay, thanks. Could just use the same. Yeah, it's these kind of like simple things that sometimes can be hard for Ruby developers. If they come to Crystal, they have to adapt a little bit. But it's not too much, I can promise. And it's really easy to run Crystal and Ruby together. So in this direction, the example here is a Ruby program which has embedded into it a method that basically gets crystallized. So this is thanks to a gem called Crystal Ruby. It was, I think, recently announced, drew some attention in Hacker News as well. And what this does, basically, it takes the body of the method wraps it into some Crystal code and builds this as a Crystal code into a dynamically linked library, and then loads that into Ruby via FFI. And then it handles all the type mappings between Ruby and Crystal, and then you can just run the code in Crystal with the speed of Crystal, but it's all embedded into a Ruby application. So I think that's really great. I'm not sure how evolved it is, like how the type mappings, probably there are some limitations, but yeah, it works really well for simple things for sure. You can also go the other way around. You can have a Crystal program, embed some Ruby interpreter. In this case, I just used a simple hello from Ruby, but you can also do like type mappings to pass stuff around between the language barriers. Of course, this is mRuby, which is a bit easier to embed into another program. And another commonly used method to combine Ruby and Crystal for a powerful combination is to delegate just some performance-critical workloads, either by embedding Crystal code into a Ruby or just having separate parts of an application, like background job processing. That's super easy to just swap a Ruby background job runner for a Crystal runner. Like there's a Sidekick library for Crystal. You can just plug that in and it runs your jobs, and it's more efficient than Ruby at doing that. Or like dedicated service backends for whatever WebSockets or streaming or all this kind of stuff, which are easily pluggable. You can just write a separate a Crystal program for that, and you get a lot of benefits. Finally, let's come to some learnings for Rubyists. One thing that happens in Crystal a lot is that you get more aware of like what types are involved in the code that you write. So first of all, this simple example is just two methods, bar returns string or nil, and foo accepts a string. I've written this abstract def thing, that's Crystal syntax, but let's assume the same applies somehow to Ruby, and the code below that runs in both. So if we have this if expression, which checks the value of the method bar, the return value, and if it's truthy, it has not a nil, then we call the foo method with the value of bar. That's great, but the Crystal compiler will complain about this because the return value of bar is string or nil, and foo accepts string. And in this case, yeah, we could know that bar must be string if we are inside this condition body, but there's no guarantee that bar returns the same value every time. So it could be the first call returns string, the second one returns nil, and then we're in a situation where we can't use that as a string. So the Crystal compiler won't let you do that. And to fix it, you'll have to assign it to a local variable, which then is sure the value stays the same. If that variable is truthy, that's not nil, then we can use it as a string. And it turns out this pattern is also like just better. Like we don't need to call bar twice, just once and then store it. And storing in a local variable, that's a zero-cost abstraction. It's easier, less calls. We don't know what kind of work bar is doing. Maybe it's just returning an instance variable. Maybe it's doing some stupid, complex calculations every time. We can't just do that only once. Another thing is, in Ruby, there's a tendency to have like semi-structured data in shapeless hashes, like ad hoc, and nobody knows what exactly the shape is supposed to be, and we pass them around to get parameters into methods. In Crystal, this is kind of problematic due to static typing. So the compiler is perfectly able to figure out what the types are, but if you remember the array example, it needs to know all the types. So the hash is similar, has like the values are generic parameters, and then you can get all kinds of types here for the hash values. So it's not very ergonomic to do this in Crystal, so that tells you to maybe do something else. So in Crystal, it's usually better to use explicitly structured type, like a class, to describe what the content is that you want there, what kind of keys are accepted, and what do they do. It also makes it more efficient, and you're able to document that and not just have some shapeless hash that maybe changes from time to time and nobody knows what exactly it's supposed to be. So the general rule here is maybe first, if your key names are static and not changing much, then it might be good to use a type or something else that is more structured than just the plain hash to have some values here. Finally, if you want to learn Crystal, there are some good resources for that. There are 2, Crystal for Rubyists. One is a bit shorter, just 1 page. The other is a short guide, multiple steps. There's also a translation table for shards for RubyGems. So shards is the name for libraries in Crystal. And just tells you, okay, if you use that RubyGem, you want the same functionality in Crystal, yeah, that's the shard to get. The exorcism track is also really, really good for Crystal. Maybe for Rubyists, it's a bit too low level, I don't know. But it really explains the language very well. So as a conclusion, I think I showed you that Crystal might be useful asset for your toolbox. It can help enhance your Ruby project, and I think if you need more performance for something, then probably Crystal could be a good idea to use instead of maybe Golang or whatever other language that is more distant to Ruby, because Crystal and Ruby, they go really well together. And I hope I shared you some ideas how knowing Crystal can make you a better Ruby developer, and the other way around, knowing Ruby makes you almost a Crystal developer, because they're so similar. So thank you for listening, and thanks for our sponsors. 84 Codes is one of the major sponsors of the language. They help us currently do a multi-threading improvement on the language. It kind of works already for a long time, and many people are using it in production. But multi-threading is still something that's not completely finished, and we are currently doing that, and it's super exciting to get even better performance for parallel workloads. So that's really awesome. Thank you, everyone.